Alright people, let's have a look at the solution to the Ferris wheel problem. So equation number 1 here is the big Ferris wheel. 43 minus 3, that is my highest point, take away my lowest point, and divided by 2 gives me my midline. I could calculate that, but I'm just putting all the numbers in here so you can see where they come from. There's my 2 pi to get rid of the radians measurement from my x-axis, and the Ferris wheel goes around once every 40 seconds, so there's my 40. Now I've had to put this plus 30 in here, and I'll explain that a little bit later on. For now I'm going to make that plus 0, and you'll see why I need to change it back to a 30 in a moment. Okay, so again on the end here's my 20, that's my 43 minus 3 divided by 2, and plus 3, which is my bottom point. So the middle of my graph is now at 23, up and down 20 from the point 23. So if I look at my graph, there it is, 0, 23, and every 20 seconds we go up and down, and 40 seconds back to our beginning of space. So I could even find that one there. And it should be right on. If I can get my mouse just wiggling enough. I saw it there briefly. There it is, 40:23. That is 1 revolution. Okay, so for our second Ferris wheel, we were given the choice of 4 equations. Why did I choose this one? Well, I chose this one because the maximum height is 8, the minimum height is 0.5, 8 minus 0.5 is 7.5, 7.5 divided by 2, 3.75. So there is my height, my amplitude. Now, I like to normally put in 2 pi, but they've just gone in with pi. If I did make it 2 pi over 30, that might make it a bit more easy to understand where those numbers come from. 30, of course, is my wavelength. Every 30 seconds, this Ferris wheel goes around, and 2 pi is in there to get rid of the radians measurement. But some people like to simplify fractions as much as I can, and you could simplify that to pi upon 15 instead of 2 pi upon 30, which is what they've done. Okay, so this 7.5 is just shifting it left and right. If that was 0, it would start there. Oops, 0. But it's not 0, it's 7.5. It's been shifted along a little bit. So what that does on my graph is it makes my beginning here at 0 seconds. So at 0 seconds, the ramp is 0. The particular carriage that Jade is going to ride in is there at the bottom of the Ferris wheel, and she can get in. And 4.25 comes from 0.5 plus 3.75, giving the middle of my graph about there at 4.25. Okay, so if I put those two on together, there are my Ferris wheels going round and round, different times and different speeds. Now, why do I need to change this to 30? Well, at the moment, the first time they're together is over here at 30 seconds. First time both the particular carriages we're concerned about are both at the bottom is at 30 seconds, but we'd rather have that over here at 0 seconds. So if I add 30, it moves things sideways. So now here it is, the bottom of my graph happening at 0 seconds. So Manu can get in. The bottom of my graph here happening at 0 seconds. So Jade and Manu can get in together. There is my 2 places happening there. Okay, so I'll click those so those disappear as well. Okay, so we've got a bottom measurement of 5 when we can first see each other. So I'm going to put in this line here when y equals 5 meters off the ground. Okay, and the maximum place is 20 meters off the ground where we can see each other. So there are the 4 lines that need to be on my graph for me to know everything I need to know. All right, so let's think about the first time that Manu can see Jade. Okay, so Manu can see Jade when she's going up, and here's the going up thing, and both of them are more than 5 meters off the ground. So here's Manu, he's 5 meters off the ground, but Jade at that point is only 2 meters off the ground. So we have to wait until this point here. At that point there, Jade is 5 meters off the ground and Manu is more than 5 meters off the ground, so they can see each other. Hello, everybody. Okay, and that carries on until this point here when Manu is now 20 meters off the ground and they can stop seeing each other. Even though Jade is carrying on above that 5 meters for a while, Manu has gone too high now to see her. So from 8.46 seconds to 9.041 seconds, there's the first period of time they can see each other. Okay, so coming back down, can't see while they're going down for some reason. Okay, Manu starts going back up, and here he is now more than 5 meters off the ground. The blue line shows that Jade is more than 5 meters off the ground. So now they can see each other again. So at the time of 42.871 seconds, they can see each other again. And that's going to carry on all the way up to either this one here where he goes more than 20 meters, or this one here when Jade goes less than 5 meters. That one happens first. So there is another section of the graph where they can see each other. So this relationship carries on. So we keep looking along here, and the next time going up is way over here, but Jade has already gone below the 5 meters. So Manu's not going to see, they're not going to see each other at all during this particular up time for Manu. So there are some answers to our graphs. We've written a correct equation and graphed it. We've chosen the correct equation and it's graphed there. We've added in our 2 boundary lines, and then we've started using the graph to answer some questions. Right, this is what we are covering today, so we'll leave that from there, and we'll see if we can do this together in our next workshop.